Why does IPython manage memory differently than Python when I delete a list? I recently learned that when you delete a list in Python, the reference of this list gets saved up within an array and gets popped out when you initialize a new list. I ran this in my regular interpreter. And as expected, I got the right result. I tried the same thing on my IPython interpreter and got false instead. Why does it happen? Is it better? Python version v3.7.0:1bf9cc 5093. IPython version 7.5.0. Update. It's happened also with different lists. And it's always happened. It's not just a random thing that they gets the same reference. Update 2. I do know why this happened. I just want to know why it's happened only on pure Python interpreter and not on my IPython, and which one of those method is better for memory management. Update 3. As I can explain the reason that those lists have the same ID, I cannot get why it is difference between IPython and Python. Look at the implementation of list_listObject.c. As we can see, there is an array of references called free_list, which the values of the array is the destroyed list objects and the count num_free for the array indexing. We can see that if there is more than 80 lists deleted, the next one won't be saved in the array. So from those lines we can say that my statement can be always true for any new Python interpreter. But I still cannot find a reason for IPython to work like this.
First, ID doesn't have anything to do with general memory management in Python the language. However, in Python, hence the IPython REPL, it has a one-to-one correspondence with raw memory locations. Some comments pointed out that the question doesn't necessarily make sense in the abstract, but restricted to IPython and the standard Python REPL it seems applicable. All that's happening is that in the processing of your cell block the IPython environment creates a few extra objects, including list objects, behind the scenes. Since the original memory space from L is taken for some of the lists that IPython created behind the scenes, the Python allocator finds a new block of memory for G. For some evidence of the extra objects, consider the following experiment run in both Python and IPython that introspects the garbage collector.
CPython